Hello everyone, welcome to this example. What we're going to do in this example is, a follow-up to the strain one you just viewed. First of all, I want to remind you that the lecture that originated these examples is going to be linked for you in the description. It's possible that I might even link the various examples with each other in the description, but if I don't, at least go back to the lecture, the reference lecture. What we have here is an example of strain. So we have an example of an axially loaded member. So you've reviewed already the example of axial stress. So we're applying a force, in this case tension, on some kind of element. Looks like a cylinder of some sort. Tensile stress is being applied because it's a force over a distance in the long direction, in the longitudinal direction of the element. If we have stress, we also have strain. And the definition of strain that I gave you during the lecture is this. Strain is equal to the change in length divided by the original length. So if we have this element, it's being in tension, right? It has axial tension in it, and so we have axial strain. The original length here is 1.670 meters, okay? And because of this tensile force, whatever that force might be, this cylinder gets longer, right, by this much, this amount of change in length. I'm going to make that up and call that 6.2 millimeters. Okay? So we have an original element of 1.67 meters. Because of this applied force, it becomes longer by 6.2 millimeters. Let's calculate the strain from our formula. So in the numerator, we're going to put the change in length, which in our case is 6.2 millimeters. The denominator is the original length, 1.67 meters. And there we go. We're ready to do this calculation, right? No. We have to make sure the units work out. How do units work out for strain? Well, there's nothing special to it other than the units have to match. Okay? Both units are units of length, but they have to match. So either we have to convert these millimeters to meters, or we have to convert these meters to millimeters. I've decided I want to convert these meters to millimeters. In my mind, it's going to be easier. In your mind, whatever else works for you, as long as the two units match. So I choose to convert this to millimeters. So 1.670 meters is 1,670 millimeters. The numerator is still the same, 6.2 millimeters. And this is great because now millimeters and millimeters cancels out. 6.2 divided by 1,670 gives us this, 0.003. I'm going to be silly, I'm going to write a whole bunch of digits. 1, 2, 5, 7, 4, 9, blah, 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 blah. Okay? Oh, look at this, no units. That's the whole thing about strain, no units. Now, if it's easier, you can convert this to a percentage, as you saw during the lecture. To convert it to a percentage, you multiply by 100%. In this case, to get 0.12, 0.371%. Because knowing it in percent then helps us figure out if this is a ductile or brittle material. If you're not sure what I'm talking about, go check out the reference lecture. And that's it. That's as simple as it is to figure out strain, axial strain. Again, change in length divided by original length. Make sure that the units match so that they cancel each other out, because strain is unitless. And if it makes more sense, convert it to a percentage so that maybe you can evaluate whether this is a brittle material or a ductile material. I hope this is helpful. Thank you very much for your time and have a lovely day.